Déjà vu, a French term meaning already seen, is a common, often unsettling, and yet strangely compelling experience where a new situation feels inexplicably familiar, as if it has been lived before. It's that fleeting moment when you walk into a new coffee shop and for a split second, a specific corner with a worn armchair and a flickering neon sign feels like a memory from a forgotten dream or even a past life. This isn't just about recognizing a type of place, it's the peculiar sensation that you have experienced this exact moment with these precise details at some point in your personal history. It's not a memory you can consciously recall, but the feeling of recognition is undeniable and often quite strong, almost like a phantom limb of recollection. The unsettling part isn't the familiarity itself, but the immediate awareness that this familiarity is fundamentally false, a glitch in your perception of time. For centuries, explanations for déjà vu ranged from spiritual premonitions to echoes of reincarnation, reflecting humanity's deep-seated need to understand these strange mental phenomena. Modern science, however, offers a more grounded, albeit still complex, perspective, moving away from mystical interpretations towards neurological and cognitive explanations. It highlights how our brains are constantly processing vast amounts of information, sometimes with slight hitches in the intricate machinery of memory formation and retrieval. This seemingly simple phenomenon actually taps into the deepest workings of our consciousness and our understanding of what it means to remember and perceive reality. It challenges our assumption that our perception of the present is always novel and unique, suggesting instead that sometimes the brain's internal mechanisms can trick us into believing otherwise. The feeling can be intense, momentarily blurring the lines between what is truly new and what the brain mistakenly identifies as a rerun. To understand déjà vu, we first need to grasp how our brain processes and stores memories. Memory isn't a single monolithic system, it's a highly distributed and complex network of processes involving multiple brain regions working in concert. When you experience something new, say encountering a specific street vendor selling exotic fruits, your brain doesn't just record it like a video camera. Instead, it encodes various sensory details: the vibrant colors of the fruits, the smell of spices, the sound of the vendor's call, the texture of the cobblestones underfoot. These individual components are then stored in different parts of the brain. The visual cortex handles the sights, the auditory cortex the sounds, and so on. When you recall that memory, your brain doesn't just pull up a single file. It reconstructs the experience by reactivating these distributed neural networks, stitching together the fragmented pieces to create a coherent whole. This reconstructive nature of memory is crucial because it means our memories are not perfect replicas, but rather dynamic, often imperfect renditions of past events. Déjà vu is thought to arise when there's a momentary hiccup in this intricate playback system. Imagine a highly sophisticated projection system where the projector momentarily plays a tiny fragment of a new film, then almost immediately plays it again, but the second playback is perceived as the original, creating a sense of already seen. This could happen due to a slight delay in the synchronization of different brain regions, or a temporary malfunction in the hippocampus, a brain area vital for forming new long-term memories and distinguishing new experiences from old ones. The brain essentially misfiles a new input as an old one, creating the illusion of a past experience that never actually occurred in that specific form. One prominent theory explaining déjà vu is the split perception or divided attention hypothesis. This theory suggests that déjà vu occurs when our brain processes a single event in two distinct ways, or at two slightly different times. Imagine you are walking into a room for the first time. If your attention is divided, perhaps you're distracted by a text message or deep in thought, you might only partially register the visual information of the room at first. Your brain takes in the general layout, the furniture arrangement, the lighting, but not with full conscious awareness. A fraction of a second later, or once your attention fully shifts to your surroundings, your brain then fully processes the exact same information, but this time with complete conscious perception. Because the brain has already pre-processed or partially registered the scene just moments before, when it fully processes it, it triggers the familiarity signal, creating the illusion that you've seen this exact moment before, even though it's merely your brain catching up to its own initial incomplete processing. It's like seeing a blurry image and then instantly seeing it in high definition. The content is the same, but the processing quality differs. This subtle temporal or attentional lag creates the feeling that the current moment is a rerun. The brain essentially misinterprets its own prior subliminal processing as a past memory. This theory doesn't require any complex neurological malfunctions, just the ordinary variability in how our attention and perception operate from moment to moment, making déjà vu a common, everyday cognitive trick. Another compelling hypothesis links déjà vu to a specific type of memory failure, a breakdown in the familiarity-based recognition system. Our recognition memory operates on two main mechanisms: recall and familiarity. Recall is when you can consciously retrieve specific details about a past event, like remembering exactly where and when you met someone. Familiarity, on the other hand, is a more nebulous feeling of knowing something without being able to pinpoint specific details, like recognizing a face but not remembering their name or context. Déjà vu is thought to occur when the brain experiences a strong sense of familiarity for a situation or object, but without the accompanying ability to recall any specific past event that matches it. It's like your brain's familiarity sensor goes off, but the recall database comes up empty. This can happen when elements of a new situation bear a strong resemblance to elements of a past experience, even if the overall situation is entirely new. For example, you might be in a new restaurant that has a similar layout, color scheme, or even a specific arrangement of tables and chairs to a restaurant you visited years ago, but which you've entirely forgotten. Your brain's familiarity system recognizes these fragmented similarities, triggering a "seen this before" signal. But because the entire experience is genuinely new, your recall system cannot find a corresponding complete memory. This mismatch between strong familiarity and a lack of specific recall creates the disorienting feeling of déjà vu. The brain is effectively fooled into thinking the entire new scene is familiar because its component parts, or their spatial arrangement, echoes something previously encountered, even if that previous encounter is now outside of conscious recall. This is why déjà vu often feels so real. The brain's familiarity system is indeed active. It's just firing without a clear, conscious memory to justify it. While déjà vu is a common experience for most healthy individuals, it's also a prominent symptom of temporal lobe epilepsy. For individuals with this condition, déjà vu can be a premonitory sign of an impending seizure, or even a part of the seizure itself, indicating an electrical disturbance in the brain's temporal lobe. The temporal lobe, located on either side of the head, is critical for processing sensory input, understanding language, and forming memories. Within the temporal lobe lies the hippocampus, an area particularly vital for memory consolidation and distinguishing new information from old. During an epileptic event, abnormal electrical activity in this region can trigger intense and prolonged episodes of déjà vu, far more vivid and disturbing than the fleeting sensation most people experience. Studying these cases has provided invaluable insights into the neurological underpinnings of déjà vu. Brain imaging studies, though challenging due to the fleeting nature of déjà vu, have shown intriguing patterns. Functional magnetic resonance imaging, or fMRI, has revealed that when people experience déjà vu, there's often increased activity in regions like the rhinal cortex, which is involved in object recognition and familiarity detection, and sometimes reduced activity in areas associated with explicit memory retrieval. These scans sometimes show a brief abnormal synchronization or desynchronization of neural activity in memory-related regions, almost like the brain's internal clock for new versus old information momentarily goes awry. The observation of déjà vu in temporal lobe epilepsy underscores the idea that even in healthy brains, there can be minor, temporary glitches in the same neural circuits that, when severely disrupted, lead to pathological conditions. It's a spectrum, with the occasional odd feeling for most and a more profound, disorienting experience for others. While neurological explanations offer a strong framework, psychological interpretations also contribute to our understanding of déjà vu's persistent feeling of realness. One such perspective relates to Gestalt psychology, which emphasizes that we perceive the world as whole, organized patterns rather than just isolated components. If you encounter a new scene where the overall configuration or gestalt strongly resembles a forgotten one, even if the individual elements are different, your brain might trigger the familiarity response. For instance, you might enter a newly built hotel lobby that has a similar spatial arrangement, color palette, and general ambiance to a forgotten grand hall you once saw in a movie or a specific layout in a video game. Your brain perceives the whole configuration as familiar even though you can't recall the specific source. Another psychological angle involves the concept of cryptomnesia, where a forgotten memory returns without being recognized as such and is instead mistakenly believed to be a new, original thought or experience. While not exactly déjà vu, cryptomnesia highlights how easily our brains can misattribute the source of information. In the context of déjà vu, it suggests that perhaps a very subtle, forgotten prior exposure to a similar scene or set of elements might be unconsciously re-experienced, leading to the strong feeling of familiarity without conscious recall. The realness of déjà vu, then, isn't just a neurological misfire. It's also a psychological phenomenon where our cognitive systems, striving to make sense of the world, sometimes create compelling but ultimately illusory connections. It's a testament to the brain's incredible pattern matching abilities, sometimes working a little too well and seeing patterns where there are only faint echoes. Déjà vu, in its fleeting and elusive nature, remains a fascinating window into the complexities of human memory, perception, and consciousness. It reminds us that our experience of reality is not always a perfect, direct reflection of the external world, but rather a sophisticated, often fallible, interpretation constructed by our brains. The feeling of realness in déjà vu stems from the brain's powerful familiarity circuits firing off, even if the conscious memory recall mechanisms aren't engaged. It's a subjective experience, deeply personal, and often difficult to articulate, yet universally recognized. Far from being a mere oddity, déjà vu serves as a reminder of the intricate and delicate balance within our neural architecture. It highlights how minor temporal lags, attentional shifts, or subtle pattern recognitions can create profound subjective experiences. Understanding déjà vu isn't just about pinpointing a single cause. It's about appreciating the layered complexity of memory formation, the dynamic interplay between conscious and unconscious processing, and the brain's constant effort to organize and make sense of incoming sensory data. It's a compelling testament to the brain's ability to, at times, trick itself, creating a vivid illusion of a past that never was in its current form. As research continues to evolve with advanced brain imaging techniques and cognitive studies, our understanding of this familiar glitch will only deepen, unraveling more about the profound mechanisms that shape our perception of time and memory. For now, the next time that peculiar sensation washes over you, consider it a brief, harmless peek behind the curtain of your own mind. A moment where your brain is playfully, yet profoundly, reminding you of its extraordinary and sometimes perplexing capabilities.